Next for us, we are going to be looking at adding in our electrolytic capacitors. So I'm going to do C1 first, and I'll use it to show you what we're doing. So C1 is polarized just like our LED, and we have a long leg and a short leg. Long leg is positive, short leg is negative. The capacitor doesn't have a flat spot like the LED. Instead, it's got a stripe on it. That grey or white stripe, especially with these rectangular symbols in it, will help us identify where the negative leg is. And that's attached to our short leg. And our long leg is positive. So this will go into C1. Now for those of you that don't know, a capacitor is made up of a number of plates going up here. And if we push too hard when we're pushing this down, what we'll do is we'll split the plates so they'll open up. That actually means the capacitor will not work very well. So we need to be very delicate. I'm leaving mine right there. I'm not going any further than that. And again, because they are quite delicate, we need to be quite quick. So this is where your practice has come in now. And we're going to solder these, and I'll show you some nice and real time while I'm talking to you. Heat, solder, done. Heat, solder, done. And that is all it takes. The quicker you are, the more reliable your quality of your electrolytic capacitor will be. And yet mine's gone a little bit wonky. Will it stop it working? Absolutely not. Does it look as nice? No, it doesn't actually. But it will still work exactly the same. So we can now do C3 and C6, which are other two electrolytic capacitors. These are identical, exactly the same component. So it doesn't matter which one goes in where, but we have to remember to get our positive and negative in the correct locations. And as soon as I feel any resistance when I put it in, that's when I stop, because I don't want to damage the plates inside. That is all the components added to our circuit board. Now we have to start on the wires. The wires, the first one we're going to do is our power wire. This is our battery snap wire. It's got red and black, and they are pre-tinned, pre-stripped, ready to go. So all we've got to do first is make our wire easy to work with. To do that, we are just going to pinch it very gently and twist and pull our wire through. And this is technical braiding. So by braiding it, what we're doing is we're making it less likely to get tangled up. It's going to look a lot neater. Make sure these top bits here don't get tangled together. As it looks neater and stops things getting tangled up, it shows that higher level thinking that you're planning and you're thinking about what things are going to be like a little bit further down the line. I've left it not perfect at the top, but we need that little bit of room for adjustment. So that is nice and neat. That's the sort of braid that we'd be looking for. And you've got these two holes that it goes in. But you've actually got 4 holes there. 2 large and 2 small. The large one's in the middle, the small one's on the outside. That's because we're going to use this to form what's known as a friction loop. And we're going to put the wires in first. Push them right up to our braid. And then we're going to bend the wire back on itself. And this bit can get a little bit fiddly. And put it into the small hole. The first hole had nothing to do with the electronics. The second hole was to do with our electrical connection. What this first hole does is it forms a loop, a friction loop. So when you pull on the wire, it's going to pull on that bit of plastic there and not pull on our solder joint. That means that our joint will stay connected and won't get damaged, and makes it a little bit more reliable. We need this on parts that are connected to anything heavy or that could get pulled or manipulated around. I'm going to solder that one straight away so that it's there and it's not going to move. That means I've got a little bit more freedom when it comes down to placing this component in, and I'm not going to struggle as much and worry about pulling it out by mistake. Okay, I've got that one in. Before I do anything, I'll solder that in. Be very careful not to solder and heat up and burn the wires. And I can now pull the remainder of that through, nice and tight, and I have one braided cable, nice and neat. And that's what we're aiming for from the battery cable, the power cable. The next step is for our speaker wire. Now to do this, we need to separate it at both ends. So split, strip, twist and tin. And you should be familiar with this process. If you've got nails like I do, you can split it like that. And you want to get around about 2.5 centimeters like that. If you don't have nails, the technique would be to use the side cutters, open it up, and then you can get either more side cutters in there or what you do have of nails in to separate it. Again, you're looking around about 2.5 centimeters, like that. We are now going to strip the insulation off to expose the wires inside. So on our side cutters, we've got a hole just here. We're going to use that hole. We're going to place a wire straight down in that hole, all the way down to there, and we're going to go about halfway about what we have exposed. So it's in there nice and firm. I squeeze tight. With this bit, I wrap it around my hand, thumb on the back in a nice straight line. I just pull, and then I've exposed the copper wire inside. I've not damaged any of those copper wires that are exactly as they were. They're just now exposed to the outside elements. And I'm going to repeat that process for the other one attached to it. So there you can see it. Pull. I've got the flat side connected or facing towards my work, and I've got the cavity side facing away from me. We've then got to do the other side as well. And I find it easier to get all of this done in one go. And that's that done. Once you've got these done, we've done the splitting, we've done the stripping, we now need to twist and tin. So to twist them, pinch and twist, and you're rotating it round so it forms a nice tight bond, a nice tight braid. And as you twist it, pull outwards, so pull away from the wire, and that keeps it nice and tight. Do all 4. There we go. Now we need to tin them. Now tinning is a process that we can use to make sure that our work stays nice and neat. It makes it easier for us to solder with, and it stops these wires from refraying and coming apart. Now to do this is nice and simple. Firstly, I place my work in my bulldog clip and I angle it down. I deliberately angle it towards the ground, so you can just about make out from my side camera here that they're aiming towards the ground, or towards my desk, sorry. And now I'm going to put a layer of solder on them. And to do this, I put a blob of solder on my tip. Nice sized blob of solder on there. I place that on the wire. Then when I place it on the wire, I'm going to put the solder into that ball and we're going to drag both of them down. And by doing this, I'm creating a layer of solder on the tip. Now what might happen is the ball might fall off. Mine's hanging off there, you can just about see it. If that happens, use your brass sponge to clean it. And that's covered most of it. It hasn't got to be perfect, but it's got to cover most of it. And that layer of solder will stop this coming apart, and it will make it really easy when it comes to soldering this wire later on. Now something's happened here on mine, and I'm quite glad it has because I can show you what to do about it. I've got blobs of solder on here. The reason I've got that is because A, this is not aiming down enough, so gravity is not helping me, and B, I was a little bit slow. So what I'm going to do now is I'm just going to heat it up and move it along. Get rid of it. Heat it up and move it along. Get rid of it. And just repeat that process. And now I have 2 tinned wires. They're not the nicest looking things, and if I'd taken a bit more time and care over it, they would have probably looked a little bit better. So now I've got all 4 of my wires nice and tinned. What I'm going to do is I'm going to prepare them for what I need them for. And the first thing I'll do is I'll take my side cutters, and towards the end I'm going to cut them at 45 degrees, like that. And that's turned a flat spot with possibly some bits fraying out and some little bit of excess solder into a nice sharp point. So be aware that this is now sharp. And what I can do with this, it makes it easier for me to put it into the holes on my circuit board. So that's now ready to go into my circuit board. We've got another friction loop system here. So I can place them inside there. And what we're looking for those of you looking for the high level marks, we'd want the insulation to go through on both parts. And you can see how quick and easy I've got that in there. Very little fit. I'm not forcing it, I'm just gently persuading it in. Now the same principle as before, we need to bend these round so they go into the holes. Because of the type of circuit we're using, we don't need to worry about positive and negative. We do need to get them in nice and neat. What this will do for us is if we have these cables exposed down here, we will end up having a short circuit because they'll touch. If they short circuit, our speaker will not work. So we need to make sure they don't do that. And as you can see right there, nice and easy, the insulation comes all the way past the friction loop. And that is now nice and neat. That's exactly how I want it. That's how I'd love to see it. I can now solder these in place, remove the excess, and the last step is soldering this to the speaker. Okay, here is the speaker we're going to use. It's a very simple basic speaker. Try and remove any excess that's attached to the back of the magnet. And you've got 2 eyelet terminals here, and we're going to change these slightly. They're quite hard to use in that configuration. So instead, we're just going to bend them up so that they're at 90 degrees. And do that for both sides. So now that we've adjusted the eyelets to make it a bit easier for ourselves by having them facing upwards, what we can do is we can use our wires and we can bend them. I'm going to bend them into a hook and almost going back on itself. And this one is going to go through this eyelet here, this terminal, and now it is going to go completely back on itself. And what I'm aiming to do is solder the 2 sides of that wire together and solder them to that terminal in one go. So you can see here, I've got both sides of the wire bent back in itself and wrapped around the terminal. We don't wrap it around again and again, it's just one loop. And what we're aiming for here is just to join it all together in one go. We're not going to go all the way down, we're only going to go here because we don't want to damage the insulation. And what I'll do, you have to be very careful with this because the speaker here is magnetic. You can see that it drags my soldering iron in. It's quite hard to pull it off. Don't do it deliberately because you'll damage it. And solder from one side, soldering iron from the other. Nice big blob. And if we have a look at that now, let's find out how well we've done. You can see that that is now all joined. That is going nowhere. I'm happy with that. And I can repeat that process for the other side. I can bend the wire around, feed it through the hole, bend it back on itself. You can see that it's actually got a bit of give in it. So I might need to put a little bit of tension on this one. I will put this in my bulldog clip, position it exactly how I want it, and then I can solder that in place. Remember, soldering iron from one side, solder from the other. And that is one soldered circuit board. The last thing we have to do is put our IC, our controller in there. This is our op-amp circuit, for those of you that are interested. Now you see that these are already quite widely spread legs. All I'm going to do is I'm just going to squeeze them together a little bit, very, very gently, just enough to get them so they'll fit in here nicely. Now what I need to be very careful of before I go any further is that I have the notch, the little groove just in here. I hope you can see it. And that camera there at the bottom. That should line up with the notch that's on here, which line up with the notch on the circuit board. So it's all lined up correctly. And that's how we know which way around it goes. I place it in, it looks like all 8 legs are going to go into those slots. I'm checking around, and then I can just gently push, make sure it's firmly connected in, and that is it done. So year 9, that is how we construct the electronic circuit for our MP3 docking station project. I hope you found this interesting. I know it's not the same as doing it yourself, but it's the closest we can get at the moment. The important things to remember with this circuit is that you're checking your work as you go along, checking your soldering, checking the quality of your soldered joints, making sure you've got your components lined up correctly, that everything is the right way around, and that you're taking your time and being safe. Okay, good luck guys.